Hi folks, welcome back to Physics with Captain Rod. Give me a moment here. I'm going to help you out with your Unit 2-1 homework number 14 we're going to discuss here. Okay, so it says something like calculate the speed of an electron and a proton that have a kinetic energy of 1.55 EVs or electron volts. So I'm going to put this down here, 1.55 EVs. It's in red because yours are probably different values. And the first thing we got to make sure we're clear on is, what the heck is an EV? So if I were to ask you, like, what is the weight of an automobile? Most of you, no doubt, would give me a number in either pounds or possibly tons. If I were to ask you for your guess as to the weight of an aspirin, or maybe a dime, you'd probably give me a number maybe in grains. All right, a grain is a very small unit of weight. Nobody in their right mind, I can't imagine somebody giving you the weight of an aspirin in tons or pounds. And similarly, we don't use the grain as a standard measurement for weight for cars. We use whatever, a unit that seems kind of suitable. Well, when you're talking about the kinetic energy of a proton or an electron, the numbers you get tend to be around, maybe 10 to the minus 18th or so joules. So the joule is just not a real great unit of energy for electrons. It's a very, very, very small unit of energy. So for that reason, the electron volt is used. And I'm just going to write down a conversion factor here. In 1 EV, that's equal to 1.6 times 10 to the minus 19th joules. So this is the conversion factor right here, going back and forth between joules and electron volts. Now you might notice, well, wow, it's the same as the charge on an electron. Numerically, that's true, and that's just because how the electron volt is defined. It's defined as the energy required accelerating an electron through a 1 volt potential difference. So that's just a consequence of how it's defined. The big thing, EVs are just energy used for electrons or protons, things on the atomic scale, and here's the conversion factor going back and forth to joules. So in this problem, take this value and get your energy, and it's a kinetic energy, by the way, in joules, using this as a conversion factor. And then just set it equal to 1/2 mv squared. And the electron mass is given in the problem, and solve that for V. Repeat for part B. It's just you're going to use a different mass because of the proton's mass is different. And then part C is a thermodynamic question. It should be no trouble at all. Once you have those speeds, you set 1/2 mv squared equal to 3/2 kT. Again, this is just called the Stefan-Boltzmann constant. Calculate the average. And you're going to have to look that up. I don't think it's in the problem here, but you're looking for a number with units of joules per Kelvin. And this will tell you the average temperature of the gas. That part C, is not super important for what we're going to be doing in class, but anyway, that's how you get that finished up. So that should get you through 14. I'm just going to end this and make another one. Have a great day.